In this lesson, I want to talk a bit more about the workflow of this effect. Especially, I want to talk about why we're going to be simulating this in a static frame as opposed to just reapplying the animation and then simulating. And I also want to go over how we're going to apply the motion of these particles onto the original glass pieces. In this case, we're kind of doing the opposite workflow. So far in all the previous lessons, we were just dealing with points and then we were creating geometry. Or in the case of the previous lesson, we had some existing geometry and we were instancing it. But what about the case when you have actual geometry, like in this case, and we're actually creating points out of it? How can we reapply the motion of those points back? So I want to cover these two concepts before we continue this effect. And I would like to show you really fast how this effect would look like if we actually use the animation and we simulate from our moving pieces as opposed to having them static. So in order to do that, one of the key things that you always need in an effect like this is the ability to be able to remove the animation and reapply it. So far we removed the animation out of these points. They're now static. They aren't moving at all. What we have to figure out is how we can reapply that animation. So it's very similar to what we did in the object level in the first lesson. It's just this time we're going to be doing it in subs. And all we need to do that is I'm going to go to this geometry, to the full geometry, and I'm going to select the windshield and just hit delete non-selected. And then I'm going to copy this and paste it, and I'm going to use it for the time shift as well. So we have our time shifted, and it looks like something else came in here. Let's see. So 3D connectivity, just that, enter. Okay, now let's copy and let's paste it. Okay, so we have our static one and we have our animated windshield. All we need now is an extract transform. And this node is very simple, same like the one at the object level. You just give it rest geometry, which is called the reference geometry, and then a target geometry, which is the animated one. And it's going to only give us one point as a result. And you can see it's going to extract the translation and rotation. And the way it does it is it stores the translation in the P attribute, and then it stores the rotation in the orient. And then we have a pivot. We're going to see how to reapply this now. So I'm going to go back here at the bottom. Let's see, we have our points. So these points aren't time dependent, right? If we move, there's nothing happening. So let's reapply the animation. And for that, I'm just going to object merge the extract transform. I just don't want to have the wire coming all the way down. So that's just going to be one point. Then I'm going to create a point bob. And this point bob is going to be the one that reapplies. So reapply the transform. And it's actually very easy. What we have to do is we just have to get all those attributes from the second input. So let's see, we're going to get it from the second input, and there's a position, and there's only one point, so it's going to be 0.0. And then we have the pivot, which is also a vector, and the final attribute is the orient, which is a vector 4. It's a quaternion. Okay, and it's very easy. The same way that we can transform stuff in subs using a transform node, here we have a transform matrix, and you can see it's actually pretty similar. You just give it the position that you want to transform, and you get your translate, rotate, and so on. And then that gives you the new position that's transformed. So in our case, I want to, first of all, subtract the position, the pivot from the position, like that. So this is a step we have to do, like it's just offset. And then the position is how much we want to translate. And now for the orient, you'll notice this is a quaternion, and this expects a vector. So that's Euler rotations. So to transform this, I'm going to go from quaternion to matrix 3. And this a quaternion and a matrix 3 are basically, it's very easy to switch between both of them. And then we're just going to do now an extract transform. And this takes a matrix as an input, and you can see it extracts it, the translation, the rotation, and so on. In our case, we want the rotation. Okay, and that's pretty much it. We can now see if we ghost the geometry. There we go. And now if we move, we can see that our points are now moving with the car. Okay, so we just successfully reapplied the transform. Okay, and the next thing would be we can go into a simulation. So for that, I'm just going to copy our previous setup. So let's see, let's go in here. We can grab all this stuff, the point bob.import and the clean. So let's go back up. Let's go here. And we can paste this. Now, let's see, we're going to have this at the very end. So we have our orient, angular velocity, all that usual stuff. Let's go into here. And let's see, we want to start now at frame maybe 1045. Then we don't need any of this. So I'm not going to, since this is a test, I don't want to do the terrain object and just select that. We can just use a ground plane for now. Let's go back to auto update. And you'll see by default, we weren't using the velocity of the car. So if we look at this, it's not really moving with the car, but let's see, let's just make a quick test without it, and then we will add the motion of the car. So let's go here. Now we need our delete. Where did it end? There we go. So we need this one. I'm going to color this node yellow, just so we remember. It's very important. This is the one that's releasing them into the simulation. Okay, and now let's hit play. And let's ghost the car. So you can see it doesn't look realistic. And that's because, so let's move this. And that's because it doesn't inherit the car's motion. So you might say, okay, it's just as simple as let's just add the car motion, right? So we can go in here and create a point velocity. The problem is that our car is moving so much. Now we'll see we'll completely overwrite those velocities that we had before. So we kind of have to combine them together. So we can do that in a point bob very easily. Okay, and now we can say this velocity, and we can maybe add them together. We can just say get the attribute, the second input, the velocity, and we have to connect the point number. Okay, and that's going to become now our new velocity. The problem is that the car's velocity is a lot higher than ours, so we can, in our case, let's see, we can multiply it. And we can give it a parameter. So let's say like 2, 3. So you can already see that we had, if we look at ours, we had stuff going outside. In this case, the velocity is so strong that we need to keep increasing, even until 8, so that we get stuff to go the opposite direction of the car. Anyways, this is going to be super explosive. Okay. Let's look at the result. And now this is just completely exploding into a mess. That's too much, so okay, let's use just a little bit, right? So it still doesn't look that good, and that is because even though it's inheriting that motion, it's not really, I guess, like traveling. Maybe it's realistic, but I wouldn't say it's realistic. But it's not traveling with the car, and like it has a massive velocity. You can see how far away it goes. I mean, this is going to continue for a really long time. So as you can see, just doing it this way is quite hard. So that's why what I recommend is just, let's forget about the transform and let's do the simulation in one place, and then we can reapply the motion. And then we're going to look at another trick to make this look good in the end. So we don't want the pieces to always like keep moving with the car. But anyways, that's for the last part of this class. The next thing I like to do, and that's just to finish going over the workflow, just so you get an idea of what we're doing. And that is, once we have this, we need to be able to reapply this motion to the glass pieces. And the last place where we have our glass pieces is here, is disassemble, I believe. Yeah, they're here. right? So these ones are still static. So I'm going to object merge them. Okay, and let's bring them over here. So this is our class geo, and the way you reapply the transformation onto them is actually really easy. You can use a node called transform pieces, and the way it works is that you just give it the geometry you want to transform, and now you need to have a name attribute, or well, at least matching point count, or unmatching point count. In our case, we don't care about the name. We're just going to make sure that the point count and the point numbers match. So in here, you have to give it your animated points, and in here, your rest points. So that is going to be our time shifted points, and it has to be time shifted to frame 1047 as well. So in fact, just to make sure this will never change, these two have to match. If they don't match, this will break. So you can see this class geo and this class will be the same. So you see we have a problem now, and that's because at frame 1047, this is empty because our simulation still has nothing, right? Our points start to appear at frame 1048 and we only have 59 of them. And that's a problem because if we look at these transform pieces, I mean, there's nothing here, right? The points are probably somewhere doing something crazy. So we need to have 4010 points. So for that, what I'm going to do is every time that we are releasing this into our simulation, so let's see, every time that these points are going into the simulation, I want to make sure that I'm removing them from here. So I'm going to say this is greater than. So as you can see, every time that chunk is being emitted, we're removing it from these points. So now what we can do is, if we merge these two, just like that. So every time that this goes into a simulation, it's deleted. So we can see that we have 4010 points, 4010, and so on. So in the end, there won't be anything here and all the points will be here. But that way we make sure that we keep a constant point count. The only problem with this is that our point numbers are changing. And you'll see we'll probably get some weird results, especially here. So it's not going to, yeah, doesn't look that pretty. So for that, it's very important that we sort. And luckily, we created our shard ID over here. Sorry, on here. Actually, we have to make sure that this doesn't delete it. So shard ID. Okay, so we have our shard ID. So we have to make sure that we're sorting based on the shard ID. Okay, like that. And as you can see, now we're actually getting our points to deform, well, to transform the glass pieces. And there's one more thing I'd like to do, and that is our orient over here is probably going to be, this shouldn't be working, actually. It should be crazy, and that's because our orient, I mean, it's random. So I want to make sure, what I like to do is just to create a wrangle. This is very simple. You can just say orient is equal to 1. We don't want this to be, basically these are going to be our static glass pieces, so they're still sitting on the window. Okay. And as you can see, that's the final workflow. So now we have managed to transform our original glass pieces based on our particle simulation, and our particle simulation is super fast. But we're going to be doing a couple of changes. So first of all, we're not going to be dealing with our animated source. It's just going to be static, right? And we're going to simulate at frame 1047. So I'm going to leave this for later. Actually, we're not going to use any of this, so I'll just delete it. The one thing we will use is this, guys. We have to go over our mass, our orientation, and that. I'm going to leave this for later. So I'll just move it there. Okay, so let's go back to our magnitude. So that's what we finished off in the last lesson. Next, we have our mass. So there's actually something very interesting with this, and that is that in all the previous examples, we were inventing our own mass. We were setting it to be random. But in this case, we actually have existing geometry. And if we look here, our assemble, these glass pieces already have a certain size. So what we need to do is to figure out which is the smallest one, which is the biggest one, and we need to give them a mass according to their actual size. So that's actually very simple. I'm going to go here. Let's see. Let's go full screen. And we have to make some space. Okay. And what I'm going to do is I'm going to measure the area of each polygon. And I'm going to do it based on their name. So like that. And what that means is that when we look here, every shard is going to have its own area. Just like that. And it doesn't seem to be, I don't think, oh sorry, that's the alpha. That's the area. So as you can see, every shard that shares the same ID, they have the same area, and that's because this is already just like basically calculating the area per shard. Next up, what I want to do is I want to fit this from 0 to 1. So for that, I'm going to make a subnetwork. So let's go in here. Let's set it to area 0 to 1. Let's go inside. And we're just going to promote, let's see, the minimum. So from primitive to detail, we want the minimum. Let's not delete the original. So min area. Let's copy and paste this, and let's call this our max area, and let's change it to maximum. Now we can go into a point bob. Okay, and then I'll just say bind the area, and then let's get those two detail attributes. That's going to be a float. From first input, it's a detail. So main area. Max area. And then we're simply going to fit this. So we will fit the area from the minimum to the maximum. And we're going to save it back onto the area. Let's see now if we have a look at this, we can, for example, make a color for it and set it based on from attribute area. And actually what a good idea would be to promote this back to a point. So let's say our area is now going to become point. And just to do a little bit of cleanup, let's delete all these detail attributes. And finally, let's add an output. Okay. Let's see, this might not be working because, let's see, we have a color there. Let's delete the alpha. There it is. And let's see, there's something going on with our area. So it's not getting fit. Okay, so it goes from 0. Sorry, and I'm doing this in a point bob. This should have been a primitive bob, so I'll just change it there. There we go. So you can see all the big pieces are white and the small ones are black. Okay, we don't need the color anymore. And now that we have that working, we can actually bypass this. We don't need to delete the alpha. We want to keep that. And the very last thing, and this is very important, is that in order to be able to have access to our area later on, since we're packing everything and then we're deleting all the contents inside the pack geometry, we need to make sure that we're transferring the area over here. And now we're going to be able to use it later on. So now that we have that, this is going to be a lot easier. We can just go into here. And we don't need a random value anymore. I mean, we'll need it for the friction, but for here, we can just bind our area. So let's connect it like that. Let's go back up. Okay, and let's say I think we're ready to go into the simulation. Just a few more things we go into there before we go there, and that is we have to add the colliders. So let's see, actually, let's see where we're at in here. So this is frame 1047. We have our release, we have our velocity. Yeah, I think the only thing we need is the colliders. So let's have a look at that really fast. So I've already done the colliders. It's super simple, and it's not worth it to spend time going over that because it's kind of like a manual work. So what I've done is I came here to the Range Rover and I just selected the geometry that I wanted to use in our simulation. So in this case, also I turned this into a solid object so that the pieces don't fall through. Let's see, I'm not using this. So I just kept deleting some parts, and I kept, let's say I kept the glass, and I'm doing a for each loop, and I'm just doing a polyfill and raying it, and I'm basically just turning everything into a BDB, just like that. And then I'm doing the same with that bottom part, and at the very end we just end with an SDF. So in this case I'm not using a collision source because our geometry, like from what I showed you before in the previous lesson, if we go low enough with our voxel size, it's going to give us that error. So this is just an alternative. Another alternative you can do is you can select, let's say that this is our geometry. This method works as well. You can just scatter points. Let's see, like, I don't know, 50,000 points, and then you can do BDB from particles. And then you can change minimum radius to 0 and your point radius scale to 0.1, for example. And let's see, you need a lot more resolution, something like that. So as you can see, you can keep going with lower and lower resolution. It's just that it ends up getting pretty heavy, and you end up needing a lot more points. But what I don't like about this is that since you have a point radius, this is actually a bit thicker. If you compare it to this one, right? Just because of the nature, just because you're copying a sphere onto there, you're basically going to have, it's not going to be as accurate. This is great for when it doesn't have to be 100% accurate, but in our case, I just went through the pieces and built this myself. So anyways, we have an SDF, that's all that matters. I called it out interior collision. And here we have our out geo. I also left, so this is useful, I just left this node. I'm actually going to leave it on from now on. Is the car with no windows on the back. And this is, yeah, just a window. Okay, let's go back out. Let's go here and let's start object merging these objects. And the reason why I'm going to object merge them is because we need to get them at frame 1047. So we're going to collide it with the car in this frame. So that's important. So we can see here we have the geo. And I'm going to transform it into this object. And now I'm going to time shift it. And again, it's going to be the same frame that we use everywhere in our simulation. That's very important. So let's paste expression. Okay, 1047. And this is going to be our collision geo. I'm going to copy this and paste it. And let's see, we want to get the out interior collision. Now that will be our SDF. Okay, and now we can bring it in here as a static object. And this one isn't going to be animated or anything. It's just going to be static, same as everything. So collision geo. Let's go into collisions, change the mode to volume sample, and I'm going to paste this. So actually I need to copy it. So Control C, Control V, want the SDF. So let's see, let's have a look at the first frame. We don't need the, I'm going to turn off the display of the ground. We don't need that. Let's see, and then just to double check, let's look at the collision guide. Let's hide the display geometry. Okay, so this is going to be great. This is going to allow our particles to move through here. So let's hide this again. Okay, and as you can see, I'm not using the terrain. And that is because we're going to actually do another simulation after this. So the whole idea of this workflow is that we're going to be simulating our particles from this static position. After the simulation, we're going to reapply the animation, but the problem will be that once the particles are on the ground, since we're reapplying that animation, they're basically going to keep sliding along with the car. So what we're going to do is we'll say, once the particles are below a certain threshold, like say, like below here, we're going to throw them into another simulation, and that one, based on their inherited velocity, we're just going to drop them onto the ground. Okay, so that's the last step we're missing, but for now, let's worry about getting this one to look okay. So let's finally see what this looks like. Okay, that looks pretty good. Actually, I want to get rid, I brought in the wrong class. I mean, it's just the display, but instead of bringing out the out geo, I think we can get the window, what is it called? Carno windows. There we go. Cool. And it looks like some things are escaping from the back. And let's see if that's related to our collision. Yeah, and I think maybe this might be too thin. But whenever you have that problem, one thing you can do is you can increase over here your substeps. Let's see if we can go to 2. Because they might be going too fast. There we go. So let's see what else we can tweak. So I think I want a bit more velocity. So let's see if actually we are, yeah. Let's see, let's just use the inherited velocity. So I want it to be a lot more explosive. Yeah, something like that, right? Because it's getting shot by a bullet. So it's really shattering. Yeah, let's see how many pieces we get going inside and outside. So I still feel like there's a bit too many pieces coming out. So let's see, let's go to maybe 0.8. I'm going to visualize the velocity. Let's see, and it seems that we stopped using the normal's direction amount. So that was actually, yeah. Let's bring it, I'd say yeah, we can start using that again. And the up bias, I think it's okay the way it is. Let's see, we can tweak this later on. Let's see, let's leave it there. Then as far as the magnitude goes, for our minimum speed, let's see, I'll just add just a little bit more, let's say 0.5. And this one we can increase it. See, I wasn't visualizing it. Okay. Maybe something like that. Okay, and let's see, maybe our mass, bounce and friction. I think we're actually going to end up tweaking this in the next sim. I think for now this is okay. So let's go back. Let's hide the velocity. Let's try again. I think it was better the way it was before. So let's see. And a good idea is to see this. We can start looking at the final result actually with the actual window pieces, so we can show all the objects. We'll probably need to be at frame 1047. It doesn't matter, we can just hide it and we can template this guy. Okay, and let's just go into flat shaded. Okay, and actually I think it was looking better when this was a lot lower. Okay, and let's look at the points again. Let's see, I just want to make a few tests. What happens if we change, let's say, our inside and outside amount all the way to in? Okay. Now we have just a few pieces. The up might be too much. Let's see, let's have them go down a bit more. And we can maybe increase the noise bias. Something like that. Okay, I think that looks okay. Okay, so now we're ready for the next part. So I'm going to go back. Let's see, we don't need to see our car anymore. Back to our sort. And that's when we're dealing with our points. So before we do anything, this will be our very last step. Now I want to take care about reapplying the animation. So let's just connect it like that. And now we can look at it from our camera. Actually, and this will be the way it looks. Actually, we can connect now. We can connect this. And let's see, let's do a flip book. And let's hit play. Okay, so I'm just looking at the beginning. And of course, this continues way too much with the car, but again, we're going to fix that later. But I think the explosiveness and the timing is working. And let's see if we go frame by frame. Looks nice. Okay, so we have to basically create another release frame because now we want to go into a separate pop simulation. So the idea behind this is that once these particles start to be near the ground, I mean, we'll have a few conditions, but I would say once they start to get away from the car, and once they are close to the ground, we want to go into a simulation. So the best way to do this actually is to do it inside our pop solver. So I'm going to start grouping these points based on their height and based on their proximity to the car. So let's go inside the PopNet, and I'm going to show you just the basics of this. So I'm going to move all this up so we can get rid of this. And I'm going to create a pop group. And this allows us to create groups based on rules during the simulation. So I'm going to call this one our below ground. And it's very important, I'm going to preserve the group. What that means is that if a point bounces off the ground and then goes back up, doesn't matter that it goes back up. Once it's below that threshold the first time, that group will be set to 1. That way we can ensure that if points, for example, start bouncing and they go inside and outside the threshold, they don't keep going inside and outside that group. Because what we're going to do afterwards is we're going to check what is the first frame that they're inside the below ground group, and that is going to become our release frame. So the same thing that we did with the emit, we're just going to do this time with this group. And let's see, in this case, I'm going to enable it, and I'm going to say, if, for example, the height, so at p.y is less than, let's say like half a meter, I'm going to be pretty generous. Then we're going to say in group is equal to 1. So it's going to add it to that group called below ground. And if we create a pop color, we can actually visualize it. So I'm going to set it to below ground. Let's see, it can be red. So let's hit play. we can see as these points start to fall below 0.4 in Y, they turn red. So that's going to be one group. The other group we can create is based on proximity. So I would say once these particles are far enough away from the car, they can also be released into the simulation. So in order to do that, I'm going to use a bounding object. So let's see, we don't need this here. So I'm going to bring in this case, this is our car. So this is our car. So I'm just going to object merge it like that. And I'm going to move this here. Okay, we can hide all the other objects. And I'm just going to use the bounds. This node is just going to create a bounding box, but the nice thing is that we have control over the padding. So for example, if we go into wireframe, and actually let's look at the car and at the bound, we can add a bit of size, a bit of padding, something like that. So let's see, like 0.2. Okay, and this is now going to become our boundary object. And I'm going to move this up again. So we're going to create another pop group. And this time I'm going to call this outside car. And again, we're going to preserve it. And this time we're going to do it based on bounding, and we can say based on bounding object. And we want to use the second context geometry. Now let's see, let's change our pop color to not show the below ground, but to actually show the outside car. So we'll see, basically this is detecting if they're inside the object. So what I want to check is if they're outside. So I'm going to invert this, and let's rerun it. And you'll see they don't have any color, and the moment they exit the boundaries of our box, they'll turn red. Okay, so we have our two conditions. We have below the ground and we have outside car. So to combine them is actually pretty easy. We're just going to go into another pop group. And we can call this one, for example, the new sim. And I'm going to preserve it. And we're going to go here to combine. And this allows us to combine groups. So we can say that the new sim, let's see. So I'll just type here, our new sim is going to be equal to the below ground. And is also going to be unioned with outside car. Okay, and now if we take a look at our new sim here, we should see that once these particles are, let's see, let's go here. Okay, for some reason it shows them like that, but once these particles are outside or below the threshold, so you can see even though these are inside the car, but since they're below 0.4, they're still going to get released into the simulation. Okay, so now we are ending up with an attribute in here. We can visualize this. Actually, it's not an attribute, but with a group. So we can color this based on, and I think we're cleaning it. Yeah, so let's make sure that we delete all except new sim. Okay, so our new sim, let's say it's going to be red. And you can see now we have this attribute outside in subs. And finally, in the next lesson, we're going to create the release frame, and then we're going to be doing our final simulation.